Hi students, have a nice day. In this section we are going to discuss about some attacking reagents, electron displacement in the covalent bonds. Okay, in the last section we discussed about the different type of cleavage, heterolytic fission and homolytic fission. Heterolytic fission creates a cation and an anion. Cations, if the positive charge is on the carbon atom, it is called a carbocation, and if the carbon atom is negative, carbanion. And homolytic fission creates free radicals, a species with the unpaired electron or unshared electron. So in this section we are going to discuss about the attacking reagents. Okay, due to the heterolytic fission and homolytic fission, some species or reagents are created. So they are called attacking reagents. The very first one is nucleophiles, and the second is electrophiles. Third one is free radicals. Okay, free radicals we already discussed. What are nucleophiles? The word phile meaning seeking or loving. Okay, first we have to discuss about the nucleophiles. Nucleophiles. The word phile means seeking or loving. So what are nucleophiles? Nucleophiles are nucleus loving or nucleus seeking species. Okay, once again, nucleophiles are nucleus seeking or nucleus loving species. What is the charge of the nucleus? Positive charge. So nucleophiles are seeking positive charge. They are loving positive charge. And therefore we can say that nucleophiles are electron rich centers. Nucleophiles are electron rich centers. That's why they are seeking positive center. Okay, some nucleophiles: Cl minus, OH minus, NO2 minus, NH2 minus, RO minus. Okay, all these are electron rich species and all these are negatively charged. Negatively charged. Very clear? So they have negative charge, they are electron rich centers, that's why they are nucleophiles. They attract the positive charge or nucleus. And also the neutral nucleophiles are there. Nucleophiles are electron rich species. Some neutral electron rich species are there. They are water, H2O, electron rich center. Ammonia, NH3, electron rich. Alcohol, electron rich. Okay, oxygen contains a lone pair, electron rich. Then ether, electron rich. Amines, NH2, electron rich. Secondary amines, R2NH, electron rich. Tertiary amines, R3N. So nucleophiles are either negatively charged or neutral molecules. So what are nucleophiles? Very simple concept. Nucleophiles are nucleus seeking or nucleus loving species. They seek a positive charge or positive center. Negatively charged nucleophiles are Cl minus, Br minus, I minus, etc. OH minus, NO2 minus, NH2 minus, RO minus, alkoxide ion. Okay, RO minus, alkoxide ion. So these are negatively charged nucleophiles. And these H2O, NH3, alcohols, either amines, secondary amine, tertiary amine, these are neutral nucleophiles. Okay, are you clear? Yes. Then second one is electrophiles. Electrophiles. What are electrophiles? Electron seeking. Okay, electron seeking reagents. Electron seeking or electron loving species. They seek electron, that is negative charge, and that's why we can say that they are electron deficient. Electrophiles are electron deficient. Electron deficient. Nucleophiles are electron rich. Remember that. Electron rich. Nucleophiles are electron rich. Electrophiles are electron deficient. That's why they are attracting, they are seeking the electron or negative charge. And some electrophiles, Cl plus. Okay, Cl plus is formed by heterolytic fission. We will discuss later. Then Br plus, NO2 plus, okay, NO2 plus, H plus, then any positively charged species, okay, any positively charged species comes under the electrophiles. Then electrophiles are also neutral. These are positively charged. SO3 plus, okay, SO3 plus is also an electrophile. H plus, Cl plus, Br plus, etc. Okay. Then neutral electrophiles are BF3. BF3 is an electron deficient compound. That's why they are neutral electrophiles. AlCl3, AlBr3, AlBr3, etc. are neutral electrophiles. Electrophiles. Okay. Yes. So electrophiles are electron seeking or electron loving species. They are electron deficient, either positively charged or electron deficient neutral molecules. So these are positively charged electrophiles. These are neutral electrophiles. And the next is a free radical. Okay, free radicals. Free radicals are formed by homolytic fission of some bonds. Okay, so you take more examples. This is about the nucleophiles and electrophiles. Next is free radicals. So in the case of free radical, we know that free radicals are formed by homolytic fission. For example, Cl and Cl in the presence of UV or heat, it forms Cl free radical plus Cl free radical. Okay. Similarly, CH3 Cl in the presence of UV light or heat, CH3 free radical plus Cl free radical. So free radicals are also an attacking reagents. Are you clear? Yes. So already we discussed, that's why I wind up the free radicals. Free radicals are formed by homolytic fission. They have unshared electron. And the stability of alkyl free radical we discussed. primary is less than that of secondary is less than that of tertiary. Okay. The next is electron movements. Electron movements. Electron movement means the pi electrons or lone pair electrons move between the atoms or move in the chain. Okay. Let's take one example. An atom Z is bonded. Okay. An atom Z is bonded with a single bond as well as a double bond. A bond is formed by 2 electrons. Okay, a bond is formed by 2 electrons. When this electron is shifted to the Z atom, what happens? It becomes Z negative and a single bond. Okay, the Z atom gains the pair of this electron is for Z and this the second electron for another atom. And that pair of electron is shifted to the Z atom. The Z atom becomes negative. Okay, the electron movement is represented by a curved arrow. You know that homolytic fission, a fish hook arrow. If the pair is completely shifted, it is represented by a full head arrow. Curved arrow, it is a full curved arrow. And then next, so what happens? The pi electron is shifted towards the atom. Another is, we take that one. Z minus 2 bonds. When this pair of electron is shifted to this side, it becomes double bond Z single bond. So a pair of electron is shifted in between the 2 atoms, a double bond is created. Are you clear? This is an electron movement. Another possibility, okay, we take this one. A double bonded Z and a single bond with the other atom. If this electron is shifted to Z atom, what will happen? It is Z, okay, a negative charge, a pair of electron is on the Z atom. So these are the different movements of electron. Okay, different movements of electron in the organic reactions. Okay, you will also go through it. Next is electron displacement effect in the covalent bond. Electron displacement effect. So we have to discuss 4 effects. One is inductive effect. Second is resonance effect. Third is electromagnetic effect, and the fourth is hyperconjugation. Okay, what are the different effects? One is inductive effect, second one is resonance effect, third one is electromagnetic effect, and the fourth one is hyperconjugation. Okay, so let's discuss one by one. The first electron displacement effect is inductive effect. As we know that carbon forms covalent bonds with a carbon atom or with another atoms. Suppose an electronegative atom is attached to the carbon atom or carbon chain. What happens? The sigma bond is polarized. Why? If electronegative atom withdraws the electron towards it, it becomes partially negative and the other atom becomes partially positive. Okay, let's take one example. The carbon chain is attached to an electronegative atom, we take chlorine atom. Chlorine is electronegative. The most electronegative atom is fluorine. Now we take chlorine atom. So chlorine attract the bonded electron towards it and it acquire a partial negative charge. Okay, a partial negative charge. So what happens for this carbon atom? It develops a partial positive charge. If this carbon is partially positive, the positive charge effect is spread into the next carbon atom. So it has a smaller positive charge. As we know that the symbol is delta. Okay. So here a delta positive is created. Here is delta positive. That means the positive charge is developed is smaller than that of positive charge developed on the first carbon atom. Okay, so first carbon is partially positive. Now we have to distinguish the carbon atom. Okay, just write the carbon atom. The first carbon is partially positive. Second carbon has positive charge but a very small charge is on the second carbon atom. So what about the third carbon atom? That carbon also positive and the positive charge is very less. Okay, the positive charge on the carbon atoms are very less. So a permanent displacement of electron along the carbon chain where some atoms or group of atoms with a different electronegativity is attached to the carbon atom. Okay, once again, inductive effect is a permanent displacement of electron along the carbon chain. Okay, along the carbon chain where some atoms or group of atoms with a different electronegativity than the carbon atom is attached to carbon chain is called inductive effect. Hope you understand. Once again, the permanent displacement of electrons along the carbon chain where some atoms or group of atoms with a different electronegativity than the carbon atom attached to the carbon chain. Okay, attached to the carbon chain is called inductive effect. So remember that it is a permanent effect. Okay, it is a permanent effect. And in this case, electronegative atom is chlorine. The electron is shifted to the chlorine atom. And such groups are called minus inductive effect or negative inductive effect. So this effect is called negative inductive effect. Inductive effect. And it is shortly written as minus I effect. Okay, so what is minus I effect? If the atom or group of atoms which attached to the carbon chain withdraw the electron is called minus I effect. Okay, then next we consider another example. The carbon chain C, X atom, an unknown atom, or Z atom, you take Z atom, no problem. Okay, an atom Z. Electron negativity of Z is less than that of the carbon. Okay, less than that of the carbon. So what happens? The electron density is moved towards the carbon atom. Okay, electron density is moved towards the carbon atom. So Z becomes partially positive, this carbon partially negative. So a partial delta negative is created here. Delta negative is here. Delta negative. Okay, in some other textbook it is written as this is delta negative, delta dash negative, delta double dash negative. Okay, both are correct. C1, C2, C3. So now the electron displacement direction in this fashion. Okay, as earlier it is towards the electronegative atom. In this case, it is towards the carbon chain. And this is called plus inductive effect, positive inductive effect. Positive inductive effect. So what is positive inductive effect? An atom or group of atom attached to the carbon chain pull or donate the pair of electron. Okay, bonded electrons towards the carbon chain is called positive inductive effect or plus inductive effect. Shortly we can written as plus I effect. Okay, plus I effect. So inductive effect is are of two types. One is negative inductive effect or minus I effect. Second one is positive inductive effect or plus I effect. Okay, in future cases the teachers refer due to plus I effect, due to minus I effect. So you remember that what is plus I effect, what is negative I or minus I effect. In plus I effect, the group which donate the pair, donate the electron. Okay, donate the electron or it pull the bond pair of electrons. Minus I effect, the atom or group of atom withdraw the bond pair of electrons. Are you clear? Yes. So these are the two effects. And remember that inductive effect is a permanent effect. Okay, inductive effect is a permanent effect. And let's discuss some groups which are included in the plus I effect and the minus I effect. First of all, minus I effect groups. Minus I effect group. So what are minus I groups? Minus I groups are the groups which withdraw the electron. NO2 group is a minus I group. And a fluorine atom is a minus I group. Okay. Then a chlorine, a bromine, iodine, OCH3, C6H5. Phenyl group, benzene ring, which withdraw the electron pair. Okay, NO2, F, Cl, Br, I, OCH3, alkoxy group. Then C6H5. And plus I groups, plus I effect groups. Plus I effect groups are alkyl group, generally alkyl groups. Alkyl groups. Tertiary carbon atom. These are tertiary carbon atom. Okay, tertiary carbon atom. Tertiary butyl group. Then a secondary carbon atom. This is tert-butyl. This is isopropyl. Okay, secondary carbon. And next is C2H5, that is ethyl, a primary. Then CH3, again it is a primary methyl group. Okay, so if the carbon chain which contains a tertiary carbon which is more plus I effect than the secondary, which is more plus I effect than the primary. Okay, ethyl group, when ethyl group and methyl group comes, you remember that CH2, CH3. Okay, plus I effect. Here is only CH3 group. Okay. And hydrogen is neither plus I nor minus I. Hydrogen neither plus I nor minus I. If a hydrogen atom is attached to carbon atom, it doesn't have plus I effect or minus I effect. Okay. The next is resonance effect. Resonance effect. Resonance effect we discussed in the 4th chapter. Resonance. What is resonance? Okay, you please refer the resonance and the resonance energy in that section. What is resonance? A single structure do not represent or do not describe the property of a molecule. More than one structure which explain the properties. These structures are called canonical structures or resonance structures, and the phenomenon is known as resonance. Okay, you know that benzene structure. Benzene. So in the case of benzene, the canonical structures are two canonical structures which explain the property of the benzene. We will discuss in detail in the 4th chapter. Okay, please refer 4th chapter. And this is the resonance hybrid. Resonance hybrid. Canonical structures or stable structure, this is resonance hybrid. And the energy between the canonical structure, okay, canonical structure and the resonance hybrid is called resonance energy or resonance stabilization energy. So all these things we discussed in the 4th chapter. Here we discuss two type of resonance effects. Okay, two type of resonance effect. One is positive resonance and the second is negative resonance, as similar to positive inductive effect and negative inductive effect. Okay, let's take the first case. Positive resonance effects. Positive resonance effects. For that, we consider the molecule aniline. Aniline. This one is aniline, you know that. So here, an atom or group of atoms which donate, which give the electron pair to a pi bonded system or a conjugated system. What is a positive resonance effect? An atom or group of atoms which is attached to the conjugated system or a pi system is called a positive resonance group, and the effect is called a positive resonance effect. Okay, let's discuss. The electron is given to this carbon atom. And what happens for this bond? The pi bond is shifted to this carbon. Please listen, it is easy, but the electron shift is very important. Okay, otherwise you feel difficulty. So what is the next structure? Resonance is represented by double head arrow, you know that. The next resonance structure or canonical structure is this carbon has a negative charge and a double bond is created. Okay, so the electron is donated by nitrogen, that's why nitrogen has a positive charge. Then our two other bonds are here. And in the next possibility, this electron is shifted to between two carbon atoms at the same time. The pi bond, the pi electron shifted to this, the fourth carbon atom. So what is the resonance formula or resonance structure? Now this carbon having the pair of electron, nitrogen is doubly bonded with the carbon atom and is with a positive charge. And this bond is there. Okay, that bond is there. No problem. And the next possibility, This electron is shifted to in between the 4th and 5th carbon atom. At the same time, the pi bond is shifted to 5th carbon atom. So here the next structure is, now the 5th carbon having negative charge, a double bond is present here, another double bond, NS2 plus. Okay, and finally the electron pair shifted to between the carbon, first carbon and the 5th carbon, sorry, 6th carbon and 1st carbon atom. So double bond is created there. Sorry. Now it's the formula as earlier. Okay, but the position of double bond changed. Here the double bond between 1 and 2, 3 and 4, 5 and 6. Here the double bond between 2, 3, 4, 5, 1, 6. This is called a positive resonance effect. Okay, positive resonance effect. Once again I explain, please listen. In positive resonance effect, an atom or group of atom attached to the conjugated system. What is conjugate system? Resonance system. Okay, the pi bonds are conjugated. Conjugated system or to a pi system is called a positive resonance effect. The group or atom which donate the electron. Okay, positive resonance effect. Here we consider aniline. Aniline is a NS2 group attached to the benzene ring. Nitrogen has a lone pair and the lone pair is donated to the ring. So what happens? The pi bond is shifted to the second carbon atom. First carbon, second, third, fourth, fifth, sixth. You know the numbering. So now the second carbon is negative charge, nitrogen is positive charge because nitrogen donate the electron. Okay, nitrogen donate the electron pair. And this is the structure. Okay, the two other double bonds are there. And the next chance, next possibility, the electron is shifted to this carbon atom. At the same time, pi bond is shifted to the 4th carbon atom. Electron movements we discussed as earlier, just now. Okay, Z atom. Electron is shifted to Z atom, that atom become negative. Okay, and the pair of electrons shifted to the other atom, it becomes neutral. Okay, a negative charge shift, it becomes neutral. Yes, the 4th carbon electron pair shifted between 4 and 5. At the same time, this pi bond is shifted to 6th carbon atom. And 6th carbon now negatively charged. And finally, the possibility is the electron pair is shifted in between 1st and 6th carbon atom. At the same time, the electron which is donated to the benzene ring is come back into the nitrogen. And it becomes aniline itself. So this type of resonance is called positive resonance. And we say that plus R effect. Okay, what is the effect? Plus R effect. Hope you understand. And the last one is minus R effect. Okay, so you practice this. Negative R or negative resonance effect. Negative resonance effect. Minus R effect. In minus R effect, the atom or group of atom which withdraw the electron from the conjugated system or a aromatic ring. Okay, let's take a nitrobenzene. Nitro group is N double bond O. Okay, NO2 group. NO2 group is represented by N double bond O. And here you know that oxygen is more electronegative. Oxygen is more electronegative. So the pi bond is shifted to this oxygen atom. So the valency of nitrogen lost. So what happens? this pi bond comes to between the carbon and nitrogen. So this carbon is positive, N double bond C, okay, or C double bond N, oxygen O minus. As you know that the electron pair, the pi electron pair is shifted to the oxygen atom, that oxygen becomes negative. The total molecule is neutral, negative charge, positive charge. And the other two pi electrons are there, pi bonds, not pi electrons, pi bond is there. The next possibility, this pi bond is shifted in between these two carbon atoms. So what happens? We have another resonance structure. A positive charge comes on the carbon atom, a double bond between nitrogen, oxygen, and is O minus. Okay. Then here is a double bond. And the next possibility, the bond is shifted to this side. You can also draw in the this direction, no problem. But easy to show inside the ring. Okay. Then what is the next structure? I wrote here. The next structure is the positive charge is on this carbon atom. Those atom loses electron, that become positive. This carbon loses electron, that's why that be positive. And electron is given to this carbon, positive become neutral. Okay, positive become neutral. Double bond N O minus. And finally, this pair is shifted to this carbon or oxygen and nitrogen at the same time. As earlier, the pi electron is shifted to the nitrogen, that comes back. And we have the chain, or we have the structure NO double bond O. Okay, it's the same structure, but the position of double bond change. Position of multiple bond or double bond change. That is called a minus R effect, negative resonance effect. First case, electron is donated to the ring or into the pi system. In the second case, the electron is withdrawn. Okay, so that is minus I effect. So two important effects, inductive effect and resonance effect. Go through it. Any doubt, you can ask to me. Next section we will discuss electromeric effect and hyperconjugation effects. Thank you.